So in this video we're going to be discussing polynomials, and you can kind of think of this video as a introduction into polynomials. We'll be talking about them for a little while here. So when you see the word polynomial, poly, you might think about polygons. Poly means many. The little part nom has something to do with numericals. So just remember poly, many numbers, something kind of like that. The actual definition we'll get into in a minute. So polynomials are made up of what are called monomials. So here we go. A monomial is a number, a variable, or a product of numbers and variables with whole number representation. So it can be a number. So if we look at examples here, 5, 6, 8, 12, those can all be monomials. A variable, so x, or y, or a, or b, or whatever, could be ab or xy, as we have a product of numbers and variables. So we have negative 7xy, that's a number, a variable, another variable, and it's a product because they're all being multiplied together. So 0.5 x to the fourth. Okay, so 0.5 is a number, we have x to the fourth. You can't have the powers, so it's okay to have the powers. But you have to have whole numbered exponents. So some other examples would be x to the fifth. That could also be a monomial. How about x to the third y squared? That could also be an example. Any products with whole number exponents. So some non-examples. So negative 0.3 x to the negative second. That is not a monomial because they have to have whole numbered exponents. So negative numbers don't count in the whole numbers. That's actually an integer. It's not a whole number. So it's got to be from 1 and on. 4x minus y. This technically isn't a monomial. It is a polynomial. The individuals 4x and y are monomials, but those two together, that is not a monomial. And 2 over x to the third, well, that is a quotient, not a product. So 2 over x to the third in a fraction form, that's not a monomial. The degree of a monomial is the sum of the exponents of the variables. A constant has a degree of 0. So it's the sum. So what does sum mean? Sum means you need to add them, right? Okay, of the exponents. So we're just basically going to add the exponents of the variables, and that's all we're going to do. A constant is just a standalone number that has a degree of 0. So let's remember that. So negative 2a squared b to the fourth, again, degree, is the sum of the exponents. So let's take a look at the exponents here. We have an exponent of 2, an exponent of 4. Well, sum means we just need to add them, so that has a degree of 6. Okay, easy enough. 4. Now 4, standalone number, that's a constant, so that actually has a degree of 0. Now 8y. Now this might be a little tricky, but, well, there is no exponent. But when you have a single variable, it's like there's a 1 there, so this one has a degree of 1. So just going through different examples here. So here's 27. We've got 3y to the fourth. The only exponent there is a 4, so that has a degree of 4. Number 28, 6k. The exponent there is that little invisible 1, so that has a degree of 1. 29, we have 2a to the third, b to the second, c to the invisible 1. 3 plus 2 plus 1 gives me 6. Number 30, 325, that's a constant, that's a standalone number, that has a degree of 0. Going to 31, 2y to the fourth, z to the third, add those exponents, gives me a degree of 7. For 32, 9m to the fifth, exponent of 5, so that has a degree of 5. 33, just a p, so just a variable, and there's that invisible 1 there, so that has a degree of 1. 34, we have 5, which has a degree of 0. So now we're going to talk a little bit about polynomials. So by definition, a polynomial is just a sum or a difference of monomials. So if you look at each of these three examples, well, basically, they have monomials, and they're either just adding or subtracting them. So just remember that. Each polynomial is made up of monomials that are just being added or subtracted together. So finding the degree of a polynomial, what we're going to do is we're going to look at each individual monomial, and we want to find the monomial with the highest degree. And that's going to be my degree of the polynomial. Okay, so for this first example, we have 4x and 18x to the fifth. Well, 4x has a degree of 1, 18x to the fifth has a degree of 5, so the highest one is 5, so that has a degree of 5. Next one here, 0.5x squared y, that has a degree of 3. This monomial has a degree of 2, and 0.75 has a degree of 0. It's a constant, just a number. And the highest one is 3, so that's my degree of polynomial. Next one, we have 4. And you really don't need to write all these down. If you can see them right away, go ahead and just write down what the highest one is. Like this one, just be a 4. So it's okay if you just see it's a 4 right away. You don't necessarily need to write all these numbers out, but it can help you. So just a few more examples. We have 5x and 6. That has a degree of 1. This one has a degree of 0, so 1 for the degree on that one. So for 2b, we have a degree of 5, 5, 4, and 0. So this one has a degree of 5. So now we're going to be writing polynomials in standard form. And what standard form means is it's a different way to write the polynomial, going from the highest degree to the lowest degree. Yeah. So in the polynomials that we're going to look at here, basically we just have to look at the exponents. Which one has the highest exponent? We're going to write that one first and go down the line, going lower and lower. So look at the monomials for letter A. We have 20x, negative 4x to the third. Keep that negative with that 4. We have a 2 and a negative x squared. So which one has the highest power? Well, we have a power of to the third here on the back of that negative 4, so this one's going to come first. Okay. And I like to cross them out when I'm done with them. Okay, which one has the next highest power? The negative x squared. So we're done with that one. And then 20x or 2, which one's going to come first? Remember, a constant or just a number has a degree of 0. So 20x is going to come next, and then a plus 2. So the standalone number will always go on the end, since it has a degree of 0. Y to the third plus y to the fifth plus 4y. Look at y to the fifth. That's my highest one there. Y to the third is my next highest. And then 4y will go on the end. So just a few more examples. Looking at all the individual monomials here, which one has the highest degree? That's going to be that x to the fifth. The next highest will be the 9, x to the third. The next will be the 4x to the second. And the last one will be a 16. And since it's positive, we'll just put a plus 16. So we have these guys, that negative 3y to the eighth is the highest. 18y to the fifth will be the next one, and 14y will be the next one. So the next thing we're going to talk about here is classifying polynomials. So polynomials can be classified based on their degree and number of terms they have. So we haven't talked about what terms are. Terms are just the number of monomials. So you probably won't hear me say monomials too often more. I'll just say terms. So remember what monomials are. They're just being separated by those addition and subtraction signs in a polynomial. So they can be classified by degree. We talked about degree. Remember, degree was your exponents, or the sum of the exponents. So if it's 0, it's a constant. So those are just the numbers. It can be linear. So if it's just a 3x or 2x for the biggest term. Quadratic. So it would have a degree of 2. Cubic, quartic, or quintic. We'll be talking about quadratic equations a little bit later on, actually in the intermediate B, so we might get to that. And then there's no really names for if it's a degree of 6 or more. They just call it a 6th degree, a 7th degree, 8th degree, 9th degree, whatever. You can also call them by a number of terms. So if a polynomial has one term, of course it is a monomial. We just talked about that. Binomial, so if it has two terms, you can kind of think of it as a bicycle. A bicycle has two wheels. A binomial has two terms. A trinomial, so again, a tricycle has three wheels, so a trinomial will have to have three terms. And then if it's just four or more, we just call them polynomials. All right, so let's just take a look at some examples and see how this works. So classifying these. So classify each polynomial according to its degree and its number of terms. So two things here. So letter A, 5x to the negative 6th. So by degree, what is the degree of this one? Well, this term has a degree of 1. This one has 0. So that one has a degree of 1. So this one is linear. So let's write that out, a linear. And then it has two terms, right? So that is a linear binomial. So just write that out like that. Looking at letter B, that one has a degree of 2. So that one is a quadratic. And how many terms does it have? That's 1, 2, 3. So that is a trinomial. And letter C, we have a degree of 7. So that doesn't have a name, so we'll just call that a 7th degree. And then how many terms does it has? It has 4. So that is a 7th degree polynomial. All right, let's do some evaluating. So evaluate each polynomial for the given value. So number 10, we got 4m minus 4 m to the third. And we need to plug in negative 2 in for m. So this is a good review of order of operations. So let's plug that negative 2 in for every m. So 4 times negative 2 minus 4 minus 4 times the negative 2 to the third. So just plug in that negative 2 for all of them. And I'm actually going to move this down here for the work. And what you're going to do on polynomials is, you notice how you have kind of three different little parts? You have this, this, and this. Now we're going to multiply those separately, or expand those exponents. So 4 to the negative 2, that's going to give me a negative 8. Then we have minus 4. Remember this piece, make sure to do the exponent part first. So negative 2 to the third will give me a negative 8. Negative 2 times negative 2 times negative 2. And then negative 4 times negative 8 will give me a positive 32. So negative 8 minus 4, that's going to give me a negative 12. And then negative 12 plus 32 will give me a straight up 20. So 20 for number 10. Number 11, I need to plug in negative 1 in for y. So we have 12 times negative 1 to the 7th minus 6 times negative 1 to the 2nd plus 8 times negative 1 to the 3rd minus a negative 1. Okay? Let's figure these guys out separately. So what's kind of neat about taking a negative 1 to a power is if the power is even, it's just going to be a positive 1, and if the power is odd, it's just going to be a negative 1. So 12 times negative 1 to the 7th, well, that's just 12 times negative 1, which is a negative 12. Negative 1 to the 2nd is just a positive 1, so this is going to be a negative 6. Negative 1 to the 3rd, that's a negative 1, so minus 8. And then minus minus 1, remember when you're subtracting a negative, that's the same thing as adding. So I have negative 12 minus 6 minus 8 plus 1, so that's going to give me a negative 18. And then these two together will give me a negative 26. And then these two together will give me a negative 25. And the last one here. So I have negative 3a plus a to the third minus 1/3 a squared for a equals 3. So negative 3 times 3 plus 3 to the third minus 1/3 times 3 squared. So these we need to evaluate separately. So negative 3 times 3, negative 9. 3 to the third power will give me 27. And then this one, make sure to square this first, so that'll give me a 9. And what is 1/3 of 9? Well, that's just 3, so minus 3. So 27 minus 9 will give me 18, and 18 minus 3 should give me 15. So, 15 for that one right there. So let's finish off this video with a physics application on how we use polynomials. So a firework is launched from a platform 6 feet above the ground at a speed of 200 feet per second. The firework has a 5-second fuse. The height of the firework in feet is given by the polynomial negative 16t squared plus 200t plus 6, where t is the time in seconds. So how high will the firework be when it explodes? So the cool thing about these polynomial expressions is, like, let's say if you wanted to find out how high it is, in this case the firework, after 1, we'll just plug 1 in for t. How about 2? Well, then plug in 2 in for t. That'll give you, it'll spit out at you how high it's going to be. So they're very, very useful, especially with physics. So, and here we had it. We wanted to find out how high it is after 5, so substitute the time in for t to find the firework's height. So we plugged in 5. So negative 16 times 5 squared plus 200 times 5 plus 6. Okay, so they evaluated that. They got negative 400 and then 1,006. Then they added them together to give me 606. So that is going to be your answer. So when the firework explodes, it'll be 606 feet above the ground.